Hello, this is the SolOhm update for March the 1st, 2016. I got version 0.02 out today of the multimeter board. I'll go ahead and tell you the highlights of the changes from 0.1 to 0.2. What we have here, the major changes were in the current sense circuit. What I have on this screen is the 0.1 version. This had used a 0.5 micro-ohm sense resistor, which if you watch some of my other videos, I realized that this is a ridiculous value to actually think about soldering when you consider that the solder joints were about 50 milliohms. This is 0.5 milliohms. This is a two-terminal surface mount resistor that is basically useless. There's also some little bit of noise in this circuit that was giving me about 50 LSBs on a 16-bit AD converter. So I basically had to redo this circuit here. This also had some high gain because this sense resistor is so small. I think my gain was up in the 2000, which is a fair amount of gain. What I ended up finding was this little guy. This is TI part INA 225. This is a programmable gain, variable output, bidirectional, zero drift. That's an important part, current shunt monitor. Basically what it is, it's a programmable gain stage that's designed to go across the shunt resistor, and it's actually programmable down here. If you kind of look down here, let me zoom into this. I have four gains, 25, 50, 100, and 200. That's going to work pretty well. And then I ended up changing this shunt resistor to a larger value. And then this is a typical application. In my design, I actually have an additional gain stage here, as well as a solid key filter. So that's what we have going over here. This is the new circuit for 0.2. I changed the sense resistor. Let me go and show you which one I used. I found, let me see, where's that guy? This guy. This is an Ohmite CS3 series. This is a 4-terminal device where you put the power current through these outer terminals, and then the sense terminals are in the middle. If you want to look at the schematic here, the sense is tied off in a very good ohmic connection to the sense resistor itself. The interesting part about this is that the derating curve at 3 watts starts at 70 degrees C, not 25 like normal derating. So this will go all the way out to above my temperature range of my meter. This is available from 1 milliohm to 50 milliohms. And the resistances, the tolerances are fairly good. That's not really that important. What's important about this is that the temperature coefficient is down around 50, or well, it's actually 60 ppm per C. So this has pretty good temperature coefficient. It could be better. It turns out this part is actually fairly expensive. In one-piece pricing at DigiKey, this part's about $14. So it's one of the pricier items. This INA 225, I was concerned that this is like an oddity part, but it's actually available from various distributors, and there's thousands of them available in the United States. So over on my schematic, what I have is this INI 225, and then I have the sense resistor here. So the power comes in. The current goes this way in this direction, which puts a positive on this side. And then here's my two gain selectors that I have running off of the IO pin. This is a gain of 2. This allows me to kick up the gain for low currents. Remember this, the currents for thin film panels could be sitting around an amp, and even at I changed this to 2 milliohms. Even at an amp, that results in 2 milliohms, 2 millivolts here, and the full gain of my A to D is a 2.1. So that's a gain of about you know, a little more than 250. So this thing puts out gain of 200. So I went ahead and added this extra gain stage. And if a customer really wants to have even more sensitivity at lower currents, I put a solder jumper in right here, which will change the gain of the circuit from 2 to well, whatever you set these resistors to. If you put it in right now with all 1Ks, this will go up to a gain of 3. So we're looking pretty good. And then I have my SolOhm key circuit right here. So this is set at a 1 kilohertz low pass filter, and then it goes off to the Maxim 1160 resistor. On the board itself, what I ended up having to do was I did a rework of the analog components. Let me turn off something over here. We don't need that on. They reordered the amplifiers in the op amps are dual op amps, so I paired them up based on functionality, whereas before they were kind of strewn across the backboard, which made the traces kind of goofy. So all the gain stages and filters are over in this section of the board, and then that 2X amplifier over here that I feed into the linear A to D converter, if I want to use that, is sitting on this side. So this actually is the majority of all the analog sections. This is the A to D that I'm currently evaluating. That's the Maxim 1170. I did go and this is that sense resistor, that 4 terminal ohmite resistor, and then this is all the same over here. This is a spark gap spark arrestor to protect the circuit so that we don't have any high voltage spikes on either the negative or the positive side. Well, that's the board there. Let me see, what else did I change? I found a supply and for picking the right SD card holder, so I redid this part of the circuit as well. And I flipped the surface mount JST connectors to the right orientation. The other thing I changed was the way that the schematic works on the reset logic. I had some pretty clever stuff up here to kind of reset the board when you have it connected on the serial port, because DTR gets dropped when the serial port opens. Turns out that didn't work very well, and I never used it. After I found out that over the airwaves firmware updates work about 5 times faster than the serial port, I just yanked all that stuff out of here. I did leave in the switches, so I can't enter the bootloader and actually do a firmware load over the serial port. But I don't anticipate doing that much beyond the initial load itself. And then I fixed up the I/O pins. There was the A to D converter data out was holding the CPU in bootloader mode because of some multiplexing of the pins during bootloader mode, which was kind of problematic. I got all that straightened out. So I made the Rev to 0.2 today. I sent it off. I got a 3-day turn, so they should be here Friday. And then I ordered some parts as well. Hopefully it'll come in on Friday. If not, I get to take the weekend off and get caught up on some of the other projects I've been working on. Monday I'm going to hit it again, solder some parts on. We'll try out the next version of the SolOhm Multimeter. Thanks for watching. This is a SolOhm update for March the 1st, 2016.